Velociraptors are dinosaurs. A velociraptor is a mini version of a Tyrannosaurus Rex. Tyrannosaurus Rex, as you remember, made these dinosaurs famous through the movie Jurassic Park. This mini little monster could grow up to nearly 7 feet in height and weighed roughly 50 pounds, compared to its close cousin, Tyrannosaurus Rex, which could grow up to 14 feet in height and 40 feet in length. The weight of a Tyrannosaurus Rex on average was about 6.8 metric tons, compared to this little teeny mini version. Got up to about 50 pounds. Velociraptor lived on Earth around 71 to 75 million years ago. That's 10,000 years before Tyrannosaurus Rex was even on the planet. These little mini monsters, Professor Thomas refers to them as... Professor, why is he calling me now? Hello, Professor. Yes. What? You're kidding me. Okay. Let me make arrangements. I'll try and fly out this evening. Yes. Thank you. Bye now. Kids, that was Professor Moracek. He said there's been a rare discovery on Kranz Island. I guess we didn't know, but in the center of Kranz Island, there are a ton of rock formations. Nobody has ever ventured that high over the top. I guess when you go over the top and down, there is a small canyon that leads you to a secluded lagoon. Well, Professor Moracek climbed over there with a couple expedition explorers and found that inside the hidden lagoon, there's a cave. Inside the cave, there is tons and tons and tons of mud. Well, they did a little bit of excavation and found a full mummified velociraptor inside the cave. He wants me to fly out tonight. Kids, I found a ticket. The only problem is I have to leave tonight at 11:30. It's a 28-hour plane ride. Once I arrive in Thailand, 28 hours later, it's another 2-hour boat ride. That means I'm going to have to cancel the Wednesday Genius Combine. This is super important, kids. The professor needs my help. Kids, well, I made it to Thailand here, and all we have to do now is take this old rickety boat 2 hours to get to Kranz Island. So let's sit back, enjoy the ride, and take in all the beautiful scenery. Whoa, kids, the water's a little bit rougher than I remember. I hope there's not like a tropical storm coming up. Wait, tropical storm? It's sunny out. Wow, look at all the rock formations. It's so beautiful here. Hey, I remember that rock. I feel like we're getting close. Kranz Island, where are you? Kids, there it is, Kranz Island. All we have to do now is park the boat. Kids, I landed at Kranz Island. I'm here at the rock face. It's a sheer cliff guarded by a bunch of monkeys. If you look around, there's monkeys everywhere. There's these old school ropes that I think are probably 500 years old. I'm not sure if I trust them, but I'm gonna need to climb up through that gorge and get to the top and then down into the lagoon. But first, I've got to get past these monkeys. Let's get going. We're wasting time. That dinosaur isn't coming to us. Oh, the first rope is over there by the roots behind those monkeys. But wait, that mama monkey, she looks pretty protective of that baby. Now all I have to do is get over this big rock. Wait, oh, oi. This monkey's in my way. I feel like he's protecting the dinosaur. There's the main rope to the top. Oh no, just my luck. It's being guarded by the fiercest monkey of the tribe. Forget these monkeys. I better get going. I don't have much time. The professor said it's about a 2-hour climb to the top, so I gotta keep moving. But man, it sure is hot here. Look at all these crazy rocks. One more of these ropes. I gotta climb up through this hole, huh? Looks like a chimney almost. Crazy. It's been almost 3 hours since the last time I checked in. And man, 2-hour climb to the top? Yeah, right. I'm so hot right now. It's over 100 degrees with pure humidity. We climbed all the way up into the top. I'm at the top of the mountain, and now I've got to go all the way down the backside into the canyon and into the lagoon. There's only one way up, one way down. I got to keep moving. Here's a quick look into the canyon. You see there's this sheer cliff I got to go down, and then at the bottom, mud and the lagoon. I got to keep moving because it's starting to get dark. Oh no, more ropes. I hope I trust them. Well, we made it. This is the lagoon. Rocks and mud. Now all we have to do is do a little bit of exploring and find that cave. It's just me and Mr. Sunkit. I'm glad I got a guide. Where is he, by the way? God, where's that cave? Hey, Somchai! Where are you? Yeah, come on, over here. We gotta find that cave. I don't want to be in here after dark. Look at all these walls. It's just one way in, one way out, and that's through that gorge. Without those ropes, I don't know if we could have made it. I don't really trust those ropes, but hey, that's all we got. Now, let's see if we can find that cave. Just a little bit further. I think that cave, it's right around the corner.
Professor, you be careful with the quicksand. With the quicksand. Be careful.
Wait, what are you saying? Quicksand? Yeah, that doesn't look... Hey, there it is! It's the cave! Gotta keep moving. Whoa. Quicksand. Hey! Some kid! Hurry up! I'm not going into that cave by myself. Hey! Did you bring the flashlight? We're gonna need it. Looks like it's awful dark in there. Alright, some kid, so here's the plan. I got my cell phone, and you got a flashlight with almost dead batteries. So let's go as deep as we can into the cave without the flashlight, and when it's absolutely too dark, we'll go ahead and turn it on. Alright? Let's go. Alright, hand me that flashlight. Man, much better. Whoa. Hey, some kid. What is that? Man, it's dark in here. Whoa. Hold on a sec. It's huge. It looks like an egg. Hey, some kid, come over here. Check this out. I wish we had more than one flashlight. Yeah, wait a second. Giant egg, but it doesn't really look like it's petrified. It actually looks pretty fresh. Look at this. Whoa. Man, it's pretty creepy in here. Somkid, are you back there? Hey, Somkid. Hello? God, I can't believe he ditched me. Ah! Ah! the hell was that? Oh my god, I'm out of here. Sunk it! Hey kids, I got a better idea. Let's go ahead and do our algebra review anywhere else besides inside this crazy cave. Kids, welcome. Brain Blaster Algebra Review with Professor Thomas. Through the gorge into the lagoon, and finally we arrive at the Algebra Review. Let's go ahead and take a quick look at what we're going to do in this workout here. So first of all, we have 9 pages. You should have a little booklet in front of you that says Junior Genius Math Algebra. The 2 concepts that we're going to work on today are elementary algebra and intermediate algebra. Here are the different subcategories we'll go over: substituting values in algebraic expressions, setting up equations, basic operations with polynomials, factoring, linear equations, exponents and radicals, rational expressions, and linear equations with 2 variables. Now, notice we are going to do this 2 ways. Professor Thomas prides himself on genius secrets. In math, there's not a whole lot of secrets. You're going to get stuff in school. It's a very specific way of doing it. So I am going to stick with the geniusy secrets. Some of the stuff that we're going to work with here towards the end, we are going to do kid logic. Kid logic is a technique of doing math in a different way. If you are uncomfortable with the kid logic and you'd like to do it the regular way, we can go ahead and have you sit down with Professor Maracek or one of the assistants if you don't understand the particular way to do it which you learned in school. My understanding of ACT preparation is we need to just get the answer and not worry about all the surplusage that goes along with memorizing all kinds of things we need to know for the ACT. My understanding is you as a kid just want the answer. So with that in mind, we will focus in on the kid logic. So here we are. It's page number 1. What we're going to do here is just progress through page 1, page 2, and page 3, the answers to the first couple problems. And then keep moving on. We have more examples on page 4, 5, 6, 7, 8, and page number 9. We'll have all the answers. Notice that there are 14 problems total, plus the 4 sample problems that will give you 18 problems total. So what I'd like you to do now is let's go back to page number 1 here. And we are going to start by having you turn this video on pause. Start with this particular problem here, number 1, and then turn the video player on after you finish the whole review. If you get stuck in the middle, what we're going to do there is you can go ahead and turn on the video for the answers and explanations. Now remember, this is a Brain Blast review. It should be fairly short and simple, so I'm going to wail through the answers. If you feel like I'm going too fast and you need to go a little bit slower, that's a great opportunity to engage Professor Maracek or one of the assistants. So with that in mind, we'll go ahead and pause the video here and we'll come on back with the answers and explanations. Keep in mind that on page 3, you have the answers for problems 1 through 4. And on page number 9, you have the answers 1 through 14. Pause the video here, work on the problems, and then come on back. The answers and explanations, according to Professor Thomas, will follow next. Problem 1, linear equations with 1 variable. The way you'll see this on test day is going to be through test scores. They're going to give you a series of test scores. You're going to average them, and there will be 1 test that's not given. So here are our test scores, 87, 88, 81. Those are the first 3 of the 4. So let's copy this down in our notes. It's part divided by whole equals the average. And when I say that, part, all of your score for your grade is going to be the parts of your exams. And since there are 4 parts to your grade, which is 4 exams, that was going to give you your average. So I simply just took 87, 81, 88, listed them off here, the first 3. Now I already know that there's 4 tests and I only have 3, so the 4th test is our variable I called x. Okay, so what we do is we add these up, 87, 81, and 88, and that is going to give us 256. Plus, we are going to add in the x, so 256 plus x. That's our top value. Now, we have 4 total tests at the bottom. Now, when you take this and divide it by 4, part divided by whole, you get the average. So if we simply do the reverse of division, which is multiplication, if we multiply 87 by 4, we will get the top value. And the top value is 256 plus x. So if we come over here, 87 times 4, right? 87 times 4 is going to give us, we'll correct this quickly, 348. And the 348 here came from here, the average, times 4, which will represent the total of the top number. That means that 348 is going to equal 256 plus x. Okay, well, if you, 2 ways you could do this. The first way you could do this is you could say 348 minus 256 is going to give you your x value, which is 92. Or what you could do is you could simply set this up as a proportion. You could say 348 equals 256 plus x, and then simply solve that. Either way you do that, you will answer choice. The answer choice you're going to get is answer choice D, 92 over here, 1D. Number 2, we're going to do 2 things here. We're going to do a quick review of polynomials and basic operations using something called FOIL, which you learned a long time ago. And then second of all, what we'll do is we will learn a secret genusy trick I learned back in college physics. So let's talk about physics first. First of all, college physics, you are going to take a word problem and you're going to translate that into a mathematical equation. It can be kind of laborious and tiresome and kind of confusing, but once you understand the super secret trick here from Professor Thomas, makes it tons and tons easier. So let's start with that. So the super trick is first spoken, last written. So when you get in something that's written out like this, you just simply, the thing you say first will be written last. Let's go ahead and make like a bracket up here, okay? 5 less than 4 times the value. So the first thing I said was 5 less. So over here in our bracket, I would write 5 less minus 5. That's the first thing spoken. So I write it last. 4 times the value. 4, and the value, let's say the value is a, because it's an unknown value. 4a minus 5 is 5 less than 4 times the value. You see how they kind of flip backwards? So that's the trick. You might want to make a note of that. Number 2, FOIL. Basically, you're going to have 2 brackets here, and foiling is going to be first, outer, inner, and last. So you got your term here will go to here, here will go to here, here you'll go to here, and here you're going to go to the last one. First, outer, inner, and last. Let's go ahead and take a look at the problem here. So the first thing that we want to do is use our new physicsy trick here. So it says, which of the following expressions is the product of 3 less? It's first spoken. So in the first set of brackets, I write it down. Here's our first set of brackets, minus 3. And then it says 3 less than twice x. So 2x. Boop. See how easy that is? That's bracket number 1. Then bracket number 2, highlight it. It says 2 more, so plus 2. We write it on the back end here because it's spoken first. 2 more of what? 2 more of 3x. 3x. That's how we set that problem up. That's the hard part. Now, the easy part is foiling. So we're going to go 2x times 3x. 2x times 3x is going to give us 6x squared. And then in the second one, outer, we're going to go 2x times 2. 2x times 2 is going to give us 4x. Now we go to the inner. Inner is here to here. So negative 3 times 3x. 3 times 3 is 9. Plus x, 9x. And there's a negative symbol on there, so it will be 9x. And then we are going to do last. So we're going to go negative 3 times 2 is 6 with a negative symbol on there. It would be negative 6. Boop. Step 3, done. Now what we have to do is combine like terms. It looks like we have a plus 4x and a minus 9x. So 9 minus 4 is going to give us our 5x, and there's going to be a negative symbol on there. So that's going to give us down over here 6x squared minus 5x minus 6, which is going to give us answer choice D over here. 2D. Number 3, what we're going to do here is substitute values into the equation here. So we have letters. Let's just substitute the values for us. Now, the best way to do this is to use the brackets to make sure that we stay on track, and take a little bit of time to make sure that you're not sloppy. So anytime you see an x, we're just going to substitute x out and put in a negative 1. So we're going to take this expression here and let's rewrite it. So we have an x here. That x goes out, and we put brackets around the x value, which is negative 1, and then we put the exponent on the outside. So here it is here. So it's 2 negative 1 to the third, and then we just simply move down in the line from left to right. Negative 3 is here, and then we have negative 1 in the brackets, and then our y value is 2. So we simply rewrite. Make sure that you do left to right and stay very organized. Now, we are going to combine terms. So it's negative 1 times negative 1 times negative 1. There's 3 negative signs in there, so it will be negative. Negative 1, negative 1, negative 1 is negative 1 times 2, as we see here, which is 2 times negative 1, which is 2. Then we come over here. Negative 3 times 1 is 2 negative signs, which is positive. And then we're going to multiply that, which is 3 times 2, which will give us our 6 value. Okay, then we go ahead and combine like terms again. We have a negative 2, and we're going to add that to a positive 6. So think of it this way. 6 minus 2 is going to be 4, which is positive. That will give you answer choice B over here. Stay organized. Take a teeny bit of extra time to make sure that you write everything out nice and clean. Don't get sloppy. Answer choice B for 3. Number 4, rational expressions. As I mentioned in the introduction, Professor Thomas likes to do things a little different here. So I'm going to use Kid Logic. Kid Logic says that math is supposed to be numbers, not letters. So anytime you see some crazy values here like R, we can simply choose a number according to the problem. Here it tells us R cannot be 2 or negative 2. So I simply just chose 5. You could have chose 3. You could have done 4. For me, I like 2. I like 5. Those are easy numbers for me to memorize, to work with. So once I did that, I took my R value, which I said now, according to Kid Logic, is 5. And then anytime I said R, I just simply put 5 in there. I rewrote this problem down here. So 5 squared is the same as R squared. 5 squared minus 5 times 5 plus 6. And then on the bottom here, I said my R value is 5, so 5 squared minus 4. Then what I did is I simply calculated this out. 5 squared is 25. 5 times 5 is 25. 25 minus 25 is 0, and then sit plus 6. So that's pretty easy to work with. It's going to be 6 on the top. That's where we get this value here. On the bottom, 5 squared, 5 times 5, 25 minus 4, as we see here. That gives us 21. Now, in step number 4, I know that one of the other geniusy secrets that we like is we like dealing with decimals. So whenever we see a fraction, we can simply go ahead and divide the top by the bottom to get it into a decimal form. It's so much easier. So 6 divided by 21 gives us the decimal 0.2857. And notice I didn't just go one decimal place, I went out a few. I just simply wrote it down, 2857. Great. Then what I did is I took my answer choices here and I plugged in 5 for our R values, and then I saw which one equals the same thing as what we have calculated out. Here is our R value, which is 5. 5 minus 3, we see here, is 2. And then here is an R value, which is 5 again. 5 plus 2 is 7. So 2 divided by 7, as we saw over here, that gives us the same thing. Super easy. So much easier than doing it the regular way here. Plus, it's kind of fun to break the rules, kid. 4 is A. All right, we're in the next subsection here. We're starting with problem number 1. Problem number 1 here, we are going to basically substitute in a number for a letter. It's kind of like kid logic, only they tell you that our x value has to equal -3. So remember, the best way to do this to stay super clean is to use those brackets. So anytime you see an x value, you throw in -3 and put brackets around it, okay? So the first thing that we do over here is we rewrite the problem. It's x squared. That means it's going to be -3. So -3, I put in brackets. You could have put a square here. I decided that I was just going to go ahead and say x squared is really x times x, or -3 times -3. Either way, you could have done that. I chose to do it this way. We continue on. It says -1. Throw that in there. Boop. And then on the bottom, it's a -3 for our x. We write that in there. And then +1. Boop. There is our problem. We set that up, and then we simply just step 2, we reduce. So -3 times -3 is a +9. That's where we get that. And then +9 minus 1 is going to be 9 minus 1, which is 8. That's where we got that. On the bottom, -3 and a +1. On the bottom, that's going to give us a -2. So here's what we have. We have a 8 on the top and a -2 on the bottom. We've seen before. What do we do now? We go ahead and convert fractions into decimals on your calculator. 8 divided by -2. Boop. That gives us -4. The correct answer for 1 is going to be answer choice A. Number 2, it's a word problem that we need to convert into an expression through algebra. So this is, kids, not to sound too much like a nerd here, but this is called the Carbonian formula. The Carbonian formula says 220 minus your age will give you what's called your maximum heart rate. That means anything above that, you will have a heart attack, supposedly. Now, there is variations to that, but for this problem, let's not worry about it. So we have 220 minus your age, and every time you have a year on the face of the earth, you subtract 1 from the 220. So if you're 15, 220 minus 15 means your maximum heart rate would be 205. Okay, then some more phraseology here. RHR is your resting heart rate, and then you have your THR, which is your training heart rate. So make sure you keep those straight. So what we have is we have our training heart rate, which is the total beats per minute. And how we come up with that is we have our resting heart rate, okay? And we have we're going to multiply that by 65% of your maximum heart rate. Now, your maximum heart rate, you said here, is 220 minus your age. And then your resting heart rate. So basically, we're going to take our information from here and we're going to put it into this formula here. So let's go ahead and do that. So let's set the problem up. So we have our maximum heart rate is 220 minus this person's age. Looks like this person's age is 43. So 220 minus 43 means the maximum heart rate is 177. Okay, so that would go here. Okay, and then it tells us that the resting heart rate is 54, so it would be 177 here minus 54, okay? And then we're going to multiply that by 65%. And then we're going to add that to the resting heart rate, which the resting heart rate was 54. So we put it all together, and that will give you your training heart rate. So let's go ahead and solve it. So we have our training heart rate is resting heart rate 54 times 0.65. We've already calculated it out up here, times maximum heart rate 177 minus the resting heart rate, which is that. This together here, 0.65 times 177 minus 54. Remember PEMDAS, that's going to give you the value that we have right over here. And then we are going to add that to 54, which is our resting heart rate from here. Add those two together, that will give us our training rate. 54 plus 79.95 gives you roughly 133.95 or 134. And that is answer choice D, using the old school Carbonian formula. It's a teeny bit outdated, kids. Newer information has come out in the subject of exercise physiology. However, it's kind of a fun problem to work. 2 is problem D. Number 3 is another Carbonian formula problem, kids. So first of all, we take the information here from the word problem and we translate it into an expression. Quite easy problem here. They're not asking you to solve it, they're just asking you to set it up. So when getting into shape, the subject's maximum number of heartbeats, H, can be determined by subtracting the age from 220. So we have 220 minus the age, and we can just represent that by A, okay? And we saw that earlier, that would be the max. We'll just label that as M. And we're going to take that and we're going to multiply that by 75%. So you just simply multiply that by 0.75. Take the information here, kind of write it out, and you see that that is going to be what you see in answer choice A for number 3. Number 4, we're all over the place, kids. It is the same problem, but it's hidden and represents a different subject matter, so to say. Is what we learned earlier. Remember, we saw a word problem that needed to be translated into an expression, and that expression we use the old format of part divided by whole, and that is going to give us the average. We just switch the subject matter around. Let's get started. So the part is on the top, so we have 8 hours at x speed, so we say 8x, throw that right here, and then we see the word and tells us that that's going to be addition. And what? 7 at 325, we add that in there. That is the parts. When we add those parts up, you see that we have 7 and 8. 7 plus 8 gives us a total of 15 hours flying time. That represents the whole flight. When we divide this by this, that gives us an average of 350 miles per hour. Average. Part divided by whole gives you the average. All right, we saw earlier in the test scores that if we take the average and you multiply it by the whole, that will give us a way to solve the parts, the top. So let's do that here. 350 times 15 is going to give us a way to solve what we see at the top. So look for something that does that. So 350, we see 350 times 15. Put a dot by answer choice E because that's what we see here. And also we see here, answer choice B. 2 times 350, that's not what we see. Out. And 350, that's out. And 2 times 350, that's out. We've reduced it just by looking at that down to answer choice B and answer choice E. Now, if you look at the top, we have 8x plus 7 times 325. That's exactly what we have here therefore will be the correct answer. Well, why is answer choice B incorrect? Answer choice B says x, and that's not what we see on the top here. We see 8x by, remember this formula, kids. Write it down in your notes. 4 is going to be E. Problem number 5, kids, what I did was a little geniusy secret here. I just call it a shortcut. So remember, you've already learned this before, nothing real big and fancy on this one. 2 negatives equal a positive. So if you look at this problem here, we have a negative here and a negative here. So what I did was I just got rid of that and the bracket, and then just made that a positive, and then made that a positive as well. And now I have just one expression here that's straight in a row, okay? So I rewrote that. 3a plus 4b plus 6a plus 3b. Boop. Number 1. Number 2, what I did is I combined like terms. I took all the a's, combined them, and I took all the b's. So I did it in 2 steps. So I took 3a and 6a, and then I added those together, and that gave me 9a down here. And then I took 4b and 3b, 4b and 3b, and that gave me 7b. And now I know that the answer's got to be 9a from here plus 7b from here. That's going to lead us to answer choice E for problem 5. Number 6, we are going to combine polynomials together here. Here is the trap on ACT test day. What they do is they give you a bunch of information, and they separate the information that can kind of go with each other and put it like on far ends of each part of the equation. So here's what I did. I came over here and I looked at the first part of the equation, and what I have here is 3a squared b. So then what I did is I went over here and I searched for this, a squared b. Is there anything that I can add to that? Because I can only add a squared b to this part. So do I have an a squared b? Here's a squared b squared. No, I can't add that to that. A b squared. Nope. A squared b squared. I can't add anything there. So that tells me that this right away is done. It stands on its own. What does that mean for our answer choice? Our answer choice has to have this exactly in it. Anything else than that is going to be wrong. So you come over here. Here is 2a squared b. That's not what we see. We have 3. So we can cross that one out for the first part being incorrect. Then we come over here. Here is 2a squared b to the third. Well, that's not even in there. That's wrong. Okay, so those 2 are out automatically. Then what I did is I came over to the next one and I said 2a squared b squared. So here is what we have, a squared b squared. Anything more with a squared b squared? Here's a, no. Oh, here's another a squared b squared. So I took this and I added it together. And that's what you see I did here in these brackets. And in these brackets, I took plus 2a squared here, and then I added it to plus a squared b squared. Okay, when I do that, you see that I come up with a positive 3a squared b squared. So that's got to be in the equation as well. Anything that is not 3a squared b squared is wrong. Here is a 3a squared b squared. We'll keep it, put a dot by that. Here is a 2a squared b squared. Well, that's wrong because we added those 2 together, so that's out. Here we have it, but it's already, the first part is already out, so that's wrong. And then this is doubly wrong. It's not 3a to the fourth. That's out, and that's out for double reasons. And then over here is not what we see here. We're looking for 3a squared b squared, and that is wrong. So the only answer choice that's going to give us the first part here, 3a squared b, good, and then we added it to that, 2a squared b squared plus a squared b squared. That gives us our 3a squared b squared, which is here. And then you see at the very end, we just simply took this because there's nothing to add to this. It's minus AB squared minus AB squared. And then we see that that's in the equation here as well. Everything is in there. You don't even really need that. All the other answer choices kind of fall out of play once you look at this whole component right here in the middle. Answer choice A for number 6, kids. Number 7, we're going to factor polynomials. So here's what I think. Whenever I see something like this, this is the end result of foiling. So right away, whenever I see this, I simply break it down and do a reverse FOIL. Let's do a quick review of what FOIL means. First, outer, inner, and last. We saw this earlier. So you go boop, 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 here to here, here to here. Okay? So once we have these brackets up here, we're going to break the x down. So we're going to go x times x in the first. When we go x times x, that's going to give us our x squared here. Okay. The second thing that I do is I look over here at the last term. The last term tells me that I have to somehow multiply in order to get that. Okay. So how do we get to 20? We could go 2 times 10. We could go 5 times 4. Those are the only ways that we can get to 20. All right. So look over here and see we have 5, 4, 2, 5, and 10. Okay, great. All right. So far, so good. So here's what I did. Put our brackets in here, and I threw our x value in there. All right. The next step, once we understand that we really only have a couple options, is to look at the middle term. So now we simply look at the middle term. Okay. Well, when we have a value, right, and we're going to add or subtract it because of the foiling part of it, that we have to come up with a negative x. If we used 2 times 10, for example, if this is 2 and this is 10, well, when we start factoring and doing the FOIL part of this, there's no way we're going to get to a negative x. But 5 and 4, we could get to a negative x, because if it was 5x and 4x and 5x was negative and 4x was positive, if we did that, that would get there. So what I did is I just stuck with the 5 and the 4, and I just threw them in there in the second part. The last thing that I wanted to do is I wanted to make sure that when I did the FOIL technique, first, outer, inner, and last, that I derived the correct symbols as being negative. A negative x and a negative 20. So how do I do that? Okay, we need to get negatives. So if we take a 4 and multiply it here by x, that's going to give us a positive 4x. And here is x times a negative 5, which is going to give us a negative 5x. A negative 5x on the back half here. And then here we said was a positive 4x. Well, you can see that right away when you do a calculation real quick here, you're going to get negative x, and that's what we're looking for. So I chose that. All right. What does that mean for our answer choices? We're looking for a factor. It could be plus 4, or it could be negative 5. Well, 10 is out. 2 is out. Positive 4, we have a negative 4. Okay, and then this is the wrong sign, so that's out. Answer choice A is the correct answer, but I'm trying to have you kids think is a systematic step-by-step approach. 1, first thing you do is brackets. 2, the next thing you do is you throw your x's in there. 3, try and figure out how do you get to 20. 2 times 10, 5 times 4, and then start throwing it in there. And even if you have to start doing a little bit of foiling to try and figure out which one is going to get there, it only will take you like, a few seconds to do something like that. You'll be able to reduce choices right away. 7, A. Number 8 is another factoring problem, and once again, we're going to do the same thing as what we did earlier in this review here. Anytime you see this, this is going to be the end result of our FOIL technique. So first thing I do is I always write the brackets down. Step number 2, I look at the first component here, it's x squared, so I simply write that in the brackets. The next thing I do is I look at the last term, 6. How can I get to 6? Write them down. There's 2 ways. 1, it's 2 times 3 equals 6, or 2, 6 times 1. Perfect. Then I look at my answer choices. Here are the numbers that I have, 2, 3, 6, and 1. 2, 3, 2, 6, and 1. Okay, so that doesn't help me a whole lot. So now what I have to do is I have to just come over here, maybe throw some numbers in here. So let's go ahead and see if we can come up with a negative 5x if we choose 2 and 3. We simply just choose 2 and 3 here, and then we do a little bit of foiling. Okay, and just how about plus, and how about minus? So if we go here to here, that is x squared, and then here to here is going to give me negative 3x, and here is going to give me positive 3x. Negative and a positive, okay, that means that the middle term is going to be negative x. That's not what we see here, so that's wrong. If we were to change this to a negative symbol, if we come over here and we say negative 2x, and here a negative 3x, that gives us a negative 5x. That's what we see in the middle, right? Up here. But when we do that, do we still get a negative 6 at the end? Here is negative 2, and we're going to go ahead and go from here to here during the FOIL technique. Negative 2 times a negative 3 gives us, with 2 negative signs, that's going to give us the wrong sign. That gives us a positive 6. That's not what we see up here. We need a negative. So right away, we know that the options on that are not going to work with 2 and 3. So what we can do is we can simply cross out answer choices with 2 and 3. We come over here, we are left with 6 and 1. So let's go ahead and just kind of throw them in here really fast, and then we're going to FOIL this out. Let's just say we're looking for a negative 5. So I think if we did that and a positive over here, so we come over here, that's going to give us x squared, and then we're going to go positive x. And then here is going to go negative 6 times x is going to be negative 6x. And when you combine those, what you're going to get is you're going to get a negative 5x. So far, so good. And then now we're going to go over here. We're going to take a look at this. We're going to go negative 6 times a positive 1, and that's going to give us a negative 6. And that is what we see in the problem up here. You see, this is kind of a tricky problem. They don't give you anything you can kind of cross out right away. I just basically just trial and error. It really doesn't take too much time. The bottom line comes down to this. Whenever you see this, automatically the first thing you should be thinking is drawing your brackets, because this is the end result of all that foiling. And if we had x squared here, you know that x times x is going to give you your x squared. 8b. Number 9 reminds me of chemistry and balancing equations. Let's get rid of that. That's from up above. So first thing that we want to do is take this and we want to try and solve for our x value. So what I did, step number 1, is I just wrote the problem out myself. Boop. Then what I want to do is distribute the 2. So you're going to go 2 times x, which is 2x, and 2 times a negative 5, which gives you a negative 10. I did that. And then continue on writing out the rest of the problem. Minus 11. Step number 2. 2x minus 10 equals minus 11. Then what we want to do is we want to isolate and get rid of the 10 on this side so we can isolate the x on its other side. So what I did was I added 10 to both sides. And here's that equal sign there. When I add 10 here, we isolate x. In this case, it's 2x on the left. And then negative 11 plus 10 gives us a negative 1. Now we have 2x instead of x, so what we do is we simply just divide by 2 to get x. And what you do to the left of the equal sign, you have to do to the right. So a negative 1 divided by 2 is going to give you a negative 1/2, which is answer choice E for problem 9. Problem 10, kids, monkey wrench, ACT, beat them at their own game. So here's what we do. Whenever we see a problem that's kind of wacky like this with fractions, beat them at their own game by simply dividing the fractions out to get it into a decimal. That means convert fractions to decimals. When we do that, let's rewrite the problem. Here we have 4 over 5. 4 divided by 5 gives us our 0.8 value here, plus we're rewriting the problem. 3 divided by a negative 10 here is going to give us a negative 0.3. Then we throw in our equal sign here, and now we have x plus 1 and 1/2. Write it out and convert the 1 over 2 into 1.5. There you have it. Step number 1, convert fractions into decimals. Now what we're going to do is we are going to combine terms that we can combine. Here we have 0.8 plus a negative 0.3. So when we do this, that comes up with 0.5, and then we look on the other side. We can't do anything there because it's x and a 1.5. Now, what we want to do is we want to isolate x by itself. So that means we need to get rid of the 1.5. So this is a positive 1.5. So if we subtract a 1.5 from this side, and we subtract a 1.5 from the other side of the equal sign, then we can get x isolated all by itself. So let's go ahead and do that. So we have 0.5 minus 1.5 gives you negative 1, and negative 1 is going to equal our x value. Look for an answer choice that says the same thing. C for problem 10. Number 11, we're dealing with rational expressions here and exponents. Looks like we're going to go ahead and divide them. So, thing to keep in mind here, quick review, when you divide exponents, we are going to subtract them. Let's get started. We have 16 divided by a negative 4. So how do we get 16? 4 times 4 is 16. So we know that we are going to have a negative 4 right away. Then it looks like we have r to the 3rd power at the top, but we just have an r here. So r to the 3rd minus r is going to give us r to the 2nd. We just simply subtract them. Over here is a little bit trickier because we have t at the top and we have t3 at the bottom. That means on the bottom, since there's more t's on the bottom, you simply subtract from the top, which means that that t value is going to go below. So it's going to be t3 minus t is going to give you t on the bottom. All right, so that's taken care of. And now you see that we have our z value on the top, z to the 5th and z to the 2nd. So subtract them. 5 minus 2 gives you on top, because there's more z on the top, 5, it's going to be z3. We look for an answer choice that gives you something similar to that. 4r squared z3 over t2, and there's a negative symbol here that basically is the same thing. B, for problem number 11, kids, remember, when you divide exponents, you're going to subtract them. And the thing to keep in mind here that you saw the wackiness is sometimes they're going to be flip-flopped around. So you saw what I did here. Make note. Number 12, kids, I used a little bit of kid logic here. Remember, I want you to feel comfortable using some kid logic in case you don't remember how to do it the fancy way on test day. So sometimes when you come across a problem and you see you know how to do it the regular way, do it a second way to make sure that you can do it both ways, kid logic way and fancy math way. So let's take a look at the kid logic way here. So the first thing that we want to do is we look at our question, and it contains x's and y's. Here it says x is larger than 0 and y is larger than 0. That opens the door for kid logic because that tells us that we can basically use almost anything we want in order to get a value for x and y. So what do? I use numbers that I'm very familiar with. X is 2, y is 3. Those are easy, low sequential numbers that are easy to work with. Then the second thing that I do is I go ahead and I plug those into the equation. So here is the square root of x, and we said x is 2, so I just simply put a 2 there. Here is a 2 for x, and we said that y is going to be 3. The next thing that I do is I convert this into a real number. So over here, the square root of 2 on my calculator, I calculate that out at 1.41. Then below, I have the square root of 2 times 3, write it out, minus the square root of 3, So we calculate this out. The square root of 2 times 3, that's 4.24. Throw in our negative symbol here, as we calculate from left to right. The square root of 3 is 1.73. We simply write it out. Boop. On the top, 1.41. divided by 4.24 minus 1.73. Combined like terms as we continue moving from left to right. 1.41, we don't have to do anything to it, so we simply put it on the top. And now on the bottom, 4.24 minus 1.73, and that will give you 2.51. Now, we've learned earlier that fractions, we always convert them into a decimal because it's easier to work with. 1.41 divided by 2.51 will give you 0.56 on your calculator. Now what we do is we simply take 2 for x, 3 for y, plug that into the problems, and find the answer that gives us 0.56. If you look at answer choice C, C is 3x plus the square root of x times y. Plug in your answers here. Our x value is going to be 2, so it's 3 times 2, plus the square root of 2 times 3. We write it out on the top. On the bottom, we have 9x, 9 times 2 minus 3. Calculate that out. That gives you 0.56. 12. Kid logic. C is the answer. Number 13, we're going to use some more kid logic. Here, this problem is asking us to find an equivalent to the expression below. So here it is here. It tells us in the statement that we cannot choose our x value as being -4. That's fine because I never choose negative numbers unless I absolutely have to. Professor Thomas likes to stick with numbers he's familiar with. X equals 2, x equals 3, x equals 5. Those are numbers that I love because I have worked with them so much and they seem to work really well, and they're easy to work with. So I said x equals 2. Then what I do is I come over here and I just simply substitute a 2 in for every time I see an x. Let's go ahead and do that. So it's x squared. So x is 2. So we go 2 squared plus 12x plus 12 times 2 plus 32 plus 32. That's our top value here. Check. On the bottom, we have x equals 2, so it's x plus 4, 2 plus 4 on the bottom. Then what we'll do in step 3 is we're going to solve. So on the bottom, let's start with that since it's the easiest. 2 plus 4 is 6. And then on the top, let's go ahead and calculate this out. 2 times 2 is 4, plus 2 times 12 is 24, plus 32 That gives us 60. Write it in on the top. Then we've seen multiple times before that we want to get rid of fractions and put it into a decimal. 60 divided by 6 gives us 10, which is a whole number. Decimals or whole numbers are much easier to work with than fractions. Now what we want to do here is we want to go ahead and look for our answer choices. When we take our answer choice, we need to come up with 10. So we said that x equals 2. 2 plus 3, does that equal 10, which is in our circle? Nope, get it out of there. 2 plus 8 equals 10, so B is going to be the correct answer. Here is 2 plus 11, that's 13, and 2 plus 16. You can see all of these are wrong. The only answer choice, using some kid logic for 13, kids, B. And finally, problem number 14, we're going to use kid logic again, kids. So let's go ahead and get started. The first thing here is we are going to simplify this expression, and there is some qualifications here that we have to abide by. So normally I like working with 2, 3, and 5. In this particular case here, it tells us that our x value is smaller than -3. So think of it on a number line here. Here is what we have is 0. And here we have -3. So if we are going to make x smaller than 3, that means it's going to be further away from the 0. So that means it's going to be either -4, -5, -6, or something like that. All right. Professor Thomas's favorite numbers in kid logic are 2, 3, and 5. We cannot use 2 and 3, so it looks like I am going to select x equals, in this case, -5. The only reason I choose -5 is because it tells us a specific standard we have to abide by. That's the only, otherwise I don't use negatives. It makes it too confusing. So here we have to use it because that's part of the problem. All right? Step 1, choose a number, and then we're going to plug it in for step 2. So step 1, we're going to choose a number. Step 2, we're going to plug it in. So what we do is we rewrite the problem. 9 minus, and we'll stay nice and clean with brackets. We see an x there, and there's a square on it. So our x is -5. And then we put the squared at the top. Boom becomes boom. Go to the bottom. X minus 3 minus 5 minus 3. Step number 3, we are going to solve. So we start on the bottom. -5 and a -3, that gives us a -8. Easy. On the top, -5 squared. 5 times 5 is 25. 2 negatives make a positive. And now we say 9 minus 25 is going to give us a -16. Step number 4, we're going to convert fractions into decimals or whole numbers by simply dividing them out. -16 divided by 8 gives you 2. This is the number we will search for when we come over here in step 5 and plug in x equals -5 to see which one of these answer choices is going to equal 2. Let's go ahead and get started. 3 times our x value, which is -5. 3 times -5, that is not 2. -5 plus 3, that gives us 2, but that 2 is negative. -5 minus 3, that gives us -8. And here we go, a negative x. So we have minus 5, which is really plus 5, plus 3, that gives us 8. See how you got to make sure that with these negative symbols you follow the train of thought. A -5 So a negative 5, which really is 5 minus 3 equals 2. And that's going to give you the only answer choice, E, for this particular problem here, kids. This one is a teeny bit tougher and a teeny bit more confusing because of that negative symbol on there. The way that we can stay nice and clean in this problem is to make sure that you use those brackets and you go in a linear fashion from left to right. Problem 14 is E. Well, kids, you made it. We're done with the algebra review. You made it just like I made it out of that crazy cave. But you know what? After I made it out of that cave, I was wondering what was really inside that cave. So you know what I did? I went around town and I asked some locals near Cranes Island. And they reported to me that years before, in the late 1980s, that the military had captured some strange flying creature they reported to look like a bat. It had a wingspan of 10.5 feet. Could this be related to what we saw in the cave? Have a look. These are real photographs. You can see the Thai military here standing around, and look at the size proportion compared to the people. It's huge. Dinosaur or bat? You decide.